ಅದನ್ನ ಕ್ಲಿಕ್ ಮಾಡಿ. Hello, good morning everyone. Welcome back to session 2. So the speaker, Dr. Arun Kumar Verma, I would like to invite for this session. So let me give a brief introduction about the speaker. So Dr. Verma, presently working as Assistant Professor in the Department of Electrical Engineering at MNIT, Jaipur. Dr. Verma earned his PhD and a Master's from IIT Delhi, India. He was postdoctoral research fellow at Energy Research Institute, Nanyang Technology University, Singapore during July 2015 to July 2016. Prior to join NTU Singapore, he worked as a visiting graduate researcher at Smart Grid Energy Research Center, University of California, Los Angeles. During September 2014 to April 2015. He has developed an experimental setup along with novel control algorithms for the implementation of three-phase grid interfaced solar photovoltaic power generation system with power quality improvement. He has also developed various EV charger topologies. His research interests include smart grid, microgrids, electric vehicle integration into the grid, bi-directional power flow, grid interfaced, and standalone solar photovoltaic. The research work accomplished by him is supported with more than 72 research papers including IEEE, IET journals. He won the prestigious Base Fellowship for Advanced Solar Research at Smart Grid Energy Research Center, University of California, Los Angeles, in the year 2014. He has conferred with prestigious POSOCO Power System Research Awards in 2016. This award has been instituted by POSOCO as an initiative to recognize and reward the innovative technological research excellence in the field of power system. He has been invited by Defense University College Ethiopia and Metal Engineering Corporation Ethiopia as an instructor for MTech program in renewable energy engineering during 2016 May to 2016 May 7th to 27th. To name as few, at present he is holding DST research funding of 4.5 crores, including Mission Innovation, Spark, and ECR. Dr. Verma is an assistant editor of Smart Grid Journal and also the member of editorial board of EPE Journal. He was guest editor of special issue of IIT Power Electronics. He is member of IEEE and served as reviewer of several IEEE transactions and international journals. With this brief introduction, I would like to welcome Dr. Arun Kumar Verma to take this session. Sir, over to you, sir.
Thank you, sir. Thank you very much. I'm basically an electrical engineer, and I think Department of Mechanical Engineering is organizing this FDP. Is it correct?
Yes, sir. Yes, sir.
Yeah. So, I mean, since I have been asked for hybrid electric vehicles, so basically,
Yes,
I'll talk about electric vehicles also same time. I will also talk about hybrid electric vehicles also. Since we are working in our lab for a few chargers basically, so in the end of my presentation, I'll talk about what exactly we are doing in our lab. I hope a few electrical engineers would also be there in this gathering. So I'll try to make it like electrical mechanical, but more on electrical side since I am a electrical engineer. Okay. So I hope it won't be outdated the other people who are in mechanical engineering basically. So I'll share my screen now. So is it visible right now?
yes, sir.
Okay.
Yes, sir. It is visible.
So basically hybrid electric vehicles, or we will say that what are the challenges in electric vehicles, why we need to go for hybrid electric vehicles. So those type of things I'll discuss. I'll request you to note down your queries. Okay. We will have a general queries also. I mean, not just to electric engineering centric only, but yeah, general queries will also be there. So please note down your queries, and at the end I'll be available for those discussions. Okay. So hybrid electric vehicles basically. So my talk is, I have some points. First of all, we will discuss why electric vehicles. Okay, what are the challenges? Since hybrid electric vehicle we are talking about, so obviously we need to discuss first why electric vehicles. Okay, this is a general discussion, not involving much technical. This is just general. Okay, so anybody can understand. Now, what are the challenges in that? That is also there. Now, what is hybrid electric vehicle? So what are the objective of those hybrid electric vehicles? What is their history, type of hybridization, how we make them hybrid, series, parallel, or something like that. Type of hybrid electric vehicles, parts of hybrid electric vehicles, then ultimately hybrid electric vehicle advantage over conventional engines, then hybrid electric vehicles challenges, future scopes, and at the end I'll introduce with my lab. We have a set up one lab at MNIT Jaipur since we have a few funding projects. So ultimately in the end I'll discuss what exactly we are doing in the lab. That is basically a technical stuff, but I'll try to make it simpler. Okay, not more technical in that. Okay, just to introduce what exactly we are doing, what we have developed in terms of electric vehicles also, those things I will discuss. So just to begin with, first thing is why electric vehicles. Okay. you know that a lot of government schemes are rolling out. Even we have a national electric mobility mission. Okay, not only India, other countries like US, Japan, China, and other European countries, they all are now electric vehicle centric. Okay, so do we have any reason why we all are moving toward electric vehicles? Okay, there was a time when the crude oil price was very cheap. Even at a time we have a low demand and supply was higher. Even you can notice that when this lockdown was there, so the per unit price of those per barrel price that come to a drastic historical low. Even those ships were floating in the sea and no takers were there. Okay. So since everywhere there's a lockdown, nobody was using their vehicles or industry was shut down. So ultimately those were the day when those ships were floating in the sea and no one was taker for those crude oil. Okay. So this is a basically another situation. I mean, some pandemic was there and this type of situation was there. But in general, if we see, demand and supply is drastically changed. Okay. Now the supply is lesser and demand is high. So now people are going for an alternative. So this is one reason, but later on I'll discuss in my slides. Basically, first thing is why electric vehicles? That is clean alternative, we can say, cost savings, domestic energy independence, cheaper to run comparatively. Even I'm using a e-cycle, which is developed by my student in a lab, and in my campus only I'm using that cycle only. Okay, so I can say cheaper to run since now I'm not bothering about crude oil. Even in a month only, I think once I have those refilling of my fuel tank or something like that. Okay, in campus I'm not using my car or my scooter, nothing, only cycle. That is basically electric cycle. So simply I can say cheaper to run, cheaper to maintain, and health benefit also. Since I'm saying hybrid, so I can do pedaling also whenever it's required. Okay. Now, what are the our government is talking about basically? Okay. So this is planned that after March 31st, 2023, three-wheelers sold in the country should be electric ones. Right now, you can see so many e-rickshaws. You have electric. Okay, a lot of e-rickshaws on the road, they are electric. But after March 31st, 2023, three-wheelers sold in the country should be electric one only. Okay. Then further, after 31st March 2025, it has proposed that two-wheelers below the capacity of 150 cc sold in the country should be electric ones only. Then further, 2017, Indian government proposed a major policy of selling at least 6 to 7 million electric vehicle in India by 2020. And now, as per the electric mobility mission, e-mobility mission, by 2030, we will have all vehicles as electric vehicles only. This is the plan, government rollout plan. Now, they are also thinking about that to install charging station with each petrol pump or each refilling stations. Okay. So these are the motivations basically to embrace electric vehicles. Domestic policy goal. Domestic policy goal basically reduce the dependence on foreign oil or crude oil simply. If we have a local market for electric vehicle, definitely job creation and economic growth. Since we are talking about just to make India 5 trillion economy. Global impact, Europe to mitigate climate change. You may heard about this Paris Declaration and all, Kyoto Protocol. China to balance growth with pollution. This is global impact basically. Okay, government around the world have allocated funding for clean technology, and ultimately energy independence. Local energy resources reduce price volatility. Then for developing nations, lower cost conventional vehicle support, economic development goal, urban air pollution. You might have heard about Delhi AQI index, air quality index, more than 500. So urban air pollution is the biggest issue. And rising oil imports to be the main driver of electrification. You know that the railways also, I mean, almost all the tracks are electrified now. Okay. just to reduce the dependency on the crude oil. China has started its goal of reducing the carbon intensity of its economy. Lack of infrastructure is a huge factor, and climate change. Basically, a lot of people are talking about, see, I told that around 14 to 15% of the basically energy related to CO2 emission, or you can say that transportation is responsible for around 14 to 15% of the carbon dioxide emission. Okay, so all those things are in the mind while we're talking about the electric vehicles. If we go back, domestic policy goal, as an Indian centric, we have some other goal. Global impacts are also there. Energy independence are there. Developing nation, they have their own goals, and climate change ultimately, because the temperature is rising. So if it rise by 1 degree, the glacier ice will melt, and ultimately there is a sea level will be high, or you can say the areas nearby the sea, they may submerge. So that is also the situation. So these are the things we are keeping in mind while talking about the electric vehicles. So this is basically worldwide global initiative, what the countries are doing in America, in Europe, in Asia, which country is doing what. Okay, so that is basically the global scenario about the electric vehicles. Now I'll come to that air pollution. Basically, as I've told you that there is one thing called air quality index. Okay, this is good when you have a 0 to 50, or this is severe when you have a 400 to 500. So in the recent past days, Delhi was in the severe air quality index. So when you have a severe air quality, this affect the healthy people also. I mean, this is a dangerous for the elderly people or children, but it severely affect the healthy person also. So it was in a just a lighter side that people who are living in Delhi, they are, I mean, each day they are smoking around I mean, one packet of cigarettes, just like that, a healthy person. Okay. So ultimately, I have told you that 14%, 14 to 15% of this air pollution is responsible, or you can say that transportation is responsible for this 14 to 15% of the air pollutions. Okay. So ultimately, we need to think about this. This is how the particular component is responsible for the greenhouse gas emission or carbon dioxide emission. You can say transport is around 14%, industry 21%, and all. So ultimately, these are the biggest green gas house emitters. China first topping the chart, then US, then India and Russia. So we are among the largest greenhouse gas emitter. These are the top 5 countries basically. Then if we see here, this is very important to think about, that only electric vehicle will solve the issue. There is a very important part of this presentation, that let's say I have an electric vehicle, okay, or hybrid electric vehicle. Ultimately, in a hybrid electric vehicle also I need a electricity to charge. Now, which type of electricity I'm using in order to charge my vehicle? Whether the electricity that is totally generated from the coal, or you can say thermal power plant, if I'm using that energy or that electricity in order to charge my vehicle, this is one thing. Or if I'm using a totally renewable energy in order to charge my electric vehicle, that is a biggest difference basically. So first of all, I'll let you know what is grid, high carbon grid and low carbon grid. I'll say high carbon grid if all the electricity generated or injected into the grid, that is coming from the coal, or you can say 93% from the coal or coal fired power plant or thermal power plant, and 7% is zero emission fuel. So such type of grid are called high carbon grid, since high carbon is involved, high carbon emission is involved when you generated the electric energy. Okay, so I hope it is clear what is high carbon grid. Second thing is low carbon grid. So low carbon grids are when you inject energy generated from the renewable energy into the grid. Means total energy in the grid that is coming from the renewable, or you can say 97% is zero emission fuel, that is renewable, and 3% is natural gas. So this type of grids are called low carbon grid. Means you emit less carbon or lowest carbon while generating the energy. Okay, so this is low carbon grid. So between high carbon grid and low carbon grid, we have a medium low, medium carbon, and medium high carbon. So you can see in the slide that what are the percentage of the energy injected into the grid when we have a medium high carbon. In medium high carbon, 27% coal, 61% natural gas. Okay, 12% zero emission fuel. Medium carbon, 0% coal, 76% natural gas, 20%, 24% zero emission fuel. Now come to medium low carbon, 50-50, 50% renewable energy and 50% natural gas. Okay, so if we charge our electric vehicle from a low carbon grid, it makes sense. Now see this. I have a one uh, combustion engine based vehicle and another is electric vehicle or plug-in hybrid electric vehicle. Okay, so I'm charging this hybrid electric vehicles or electric vehicles from uh, a grid which is having a high carbon grid, or I'm charging those electric vehicle or plug-in hybrid electric vehicle from a high carbon grid. So I'm comparing those vehicles with the combustion engine based vehicles, okay, or conventional vehicles which we have right now, fuel based engines. Okay, so you see the emission level, carbon dioxide emission 11.7, 11.9, 12.2, 11.8, and for plug-in hybrid electric is the 9.3, 9.4, like that, and here it's just 13. So doesn't make a much difference when we have a 13 here and 11.7 or 12 here. So doesn't make a much sense if you are charging your electric vehicle or plug-in hybrid electric vehicle with a high carbon grid. Now same thing if you charge it with a low carbon grid, you see the emission level. Here you have emission of around 4, 3.9, 3.8, 3.5, and here you have 13. So it makes sense basically that if you charge, see, you own the electric vehicle, it doesn't make sense. But if you charge it from a grid which is basically low carbon grid or renewable energy grid, then it make a sense. It make a real difference basically. So this is a basically comparison on low carbon grid. Okay. Further, if we move further, why electric vehicle? So reduce fuel assist. Simple. I have given one example that I'm using an electric cycle. I'm not using my car or my scooter in a campus. Whenever I have to go out, then only I'm using my car. Otherwise, in a campus, I'm just riding my cycle. So I can do pedaling also. I can run in an electric mode also. Simple. So reduce fuel usage when you use electric vehicles. Definitely reduce fuel assist and reduce greenhouse gas emissions. Now see this. I told you in the beginning that why we are moving toward electric vehicles. Okay, this is a world oil production and this is the world oil demand. So you can see at a time in 1970 you have your production was at high level and demand was low, so the price was cheaper. Okay, and once this start decreasing, the gap between demand and supply start increasing, the prices start high, and then ultimately you can see future 2050. So we need to think for option, because if crude oil is not there, world is not going to stop. We need to think of the alternatives. Okay, and this is basically the temperature rise. Okay, the mean temperature rise. So if this temperature rise, what are the global impact? That is also an issue. So we need to commit it to emit less carbon dioxide in the atmosphere, so that at least we can save the global environment. So this is also one concern. Now, various emissions from the ignition engine, such as carbon dioxide, carbon monoxide, volatile or nitrogen oxide, particulate matter, carbon monoxide, these are the harmful for the environment, or those are basically called greenhouse gas emissions. Okay. Now, most of the observed increase in the globally average temperature since the mid 20th century is very likely due to the observed increase in the greenhouse gas contributions. Okay, so this is some Paris Agreement I already talked about. So these are the basically reason. If you have no fuel, no emission. So these are the advantage. Yeah, cheaper to run. We can say right now. But I have some challenges also. I have listed some challenges. These right now you are seeing the glossy picture that why we need to go for electric vehicle. But some challenges are still there. I'll discuss about those also. So ultimately, yeah, this is a internal combustion engine. This is basically I'm dividing into the classification basically. Hybrid electric vehicles, mid hybrid electric vehicles, full hybrid electric vehicles, extended range electric vehicles, parallel hybrid electric vehicles, series hybrid electric vehicles. So I'll talk about all those things. Okay, complex hybrid electric vehicle or plug-in hybrid electric vehicles, and one is battery electric vehicle. So that is also based on fuel cell. Now this is a comparison. Already I've talked about that how the electric vehicles are less emission free if you are charging from a low carbon grid. Okay, so this is a comparison basically. This is a comparison between internal combustion based electric vehicle or electric vehicles. So the comparison in terms of the greenhouse gas emissions. So this is just a comparison. Now further we'll come to that internal combustion vehicle and the electric vehicle. So that is basically tank to wheel analysis. Tank to wheel means we have a petrol tank, or the ultimately we are coming on the road. So those are the efficiency basically analysis, that if we start from the electric vehicle 100% and up to battery 98%, and ultimately at wheel we have around 72%. But if we talk about those internal combustion based engines, that is around 16% only. So this is a comparison in terms of, now this is well to wheel means well that is where we are doing the extraction of the crude oil and from the wheel. I mean, when you are coming from the well, oil well, there in terms of crude oil. So crude oil goes to refinery, then power generation, power transmission, battery charging, ultimately battery electric vehicle 18%, and here you have around 13% in an internal combustion based engine. Now this is fine up to here, that we have a glossy picture of electric vehicles, that we should go for electric vehicle, lot of pollution, air pollution, health issues, or maybe the climate change, or maybe the our economy, and so many things are there that we should go for electric vehicles. Okay, one reason is cheaper also. But what are the challenges? So I'll have include only one slide for those challenges. Basically, we can have electric vehicles, we can also have hybrid electric vehicles, but ultimately what are the challenges? So this is basically challenges based on technical challenges, infrastructure wise challenges, market wise challenges, or policy wise. So this one slide is sufficient to describe what are the challenges right now we have in electric vehicles. So once we come for technical challenges, basically one is efficiency of battery, driving range of electric vehicle, charging time, safety, and environmental impact. Basically, I give an example of my cycle. Okay, I charge it once in a week or once in a 10 days. The battery rating is 10 ampere hour. Okay, it took around 2 hours almost in order to get fully charged. I charge it in a single charge, it runs around 35 kilometer. Okay, and my house and my office hardly 1 kilometer or 1.5 kilometers. Okay, or let's say if I go for playground or whatever. So I mean, my radius or the moving distance is not more than 5 kilometer in a whole day in a campus itself. Okay, so if I charge it once and it go for a 35 kilometer, then it's fine for me. I mean, I can travel for a week, and after 1 week I can also charge it, no issue. But the first challenge is efficiency of battery. See, this is fine for a campus ride. Okay, but if I have to go from Delhi to Jaipur, this is around 300 kilometer. So can I have a battery which can run up to 300 kilometer, one thing, and can come back? Okay, this I have to think out. Driving range of the electric vehicles, basically this is a concern. So if I have a city like Singapore, 35 kilometer or 50 kilometer radius, okay, this is fine, you charge it, you move around. See, 1 kilowatt hour is roughly around 6.6 kilowatt, sorry, one kilowatt is give you 1 kilowatt will give you around 6.6 miles. Okay, so ultimately 10 kilowatt hour battery will give you around 80 kilometer or 90 kilometer, something like that, average of approximately. Okay, so this is fine for a city like Singapore or maybe Jaipur within the radius. Okay, but if you have a long distance travel, you want to go to Delhi or maybe 500 kilometer or 1000 kilometer, then what you will do, since Whenever we are going to refilling station or fuel station, it took hardly 3 to 5 minutes in order to get your tank full. But if you are having a battery based vehicle, so charging time is also high. You don't have a time that you wait for 1 hour or 2 hours to get a charge and start your journey. No, nobody has such patience. Okay. So these are the issues basically. uh, we are struggling with the efficiencies of batteries, driving range of batteries, charging time, and safety. Okay, so ultimately we need to come over that. We have a lead acid battery. Okay, the e-rickshaws in which a lot of people might have traveled. That e-rickshaws having around 48 volt and 100 ampere hour battery. So moving around 80 kilometer or something in a whole day. Okay. Now, safety is also concerned. Battery, if you charge lithium-ion battery without any smart charging or without any particular coordinated charging, it can act as a bomb. Okay, or a proper battery management system should be there in order to charge that battery. So these are the basically technical reasons why we have some hindrance. Okay, in order to adopt those electric vehicles. I told you for a small distance, things are fine. You have a just like you have a two wheelers. You have a e-scooters also. Okay. Now, infrastructure point of view, charging infrastructure. You know that whenever you purchase any vehicle, you have a lot of refilling stations, service stations, and so many things. But if you buy an electric vehicle, do you have enough charging infrastructure? In our campus, we have 4 or 5 charging infrastructure, charging point, but nobody is having a electric car. So ultimately, even last week, I heard that Nitin Gadkari he told that they are putting a charging station at each uh, petrol pump or refilling stations. So this is one thing. Now, second thing is a smart grid. See, let's say in a city of a population of 50 lakh people, around 1 lakh or 2 lakh people have electric vehicles. So once they charge, this is acting as a load on the grid. Okay. So do our grid, whether our grid are capable of handling this type of load. This is basically an intermittent load. We don't know the exact timing when they will plug in, when they will plug out. So we need to think that whether our grid are capable of handling those loads or not. Battery recycling. A lot of batteries will be coming out of the vehicles when they totally drained out. So do we have a recycling process for whole battery? Otherwise, it will be a kind of e-waste. It would be a kind of a e-waste. So do we have the handling of such type of waste? Okay. Then further, one more thing is basically when we are talking about the infrastructure, battery swapping stations. Okay, let's say in my cycle I have a two batteries. One in the working mode right now. One is fully charged but kept as ideal. Okay, I can with the help of my mobile app I can when my first battery get discharged, with the help of my mobile app I can say that my another battery which is fully charged or in a idle mode can shift to the working mode now, and I can go to this recycling station and I can ask that this battery is drained out, you keep it, give me a fully charged battery. Okay, so a battery will always be there as a you can say reserve. Okay, so that your the reliability is increased, reliability will be increased. Since you know that once my first battery get discharged, I have another battery, I can use this. So recycling stations, battery recycling stations should be there in the infrastructure. Okay, so till now we have discussed about technical or infrastructure. Now policy, basically our policies are responsible for so many things. Basically, if you have a good policies, definitely it will attract the masses. Any policies which is lucrative definitely attract masses. For example, can we reduce the tax on electric vehicle, just like we are giving subsidies on fossil fuels? Okay, electricity tariff policies, or maybe we can say that people who are having those electric vehicles, no toll tax will be charged from them. They can have a separate path for this electric vehicles, something like that. So policy initiatives are basically big thing in order to adopt those vehicles. Now, if we come to market, testing and certification, vehicle servicing. So ultimately, for example, we need a testing and certification of our vehicles. Okay. For example, I have a cycle which run at a 25 km per hour. The maximum speed of the cycle is 25 km per hour. For up to this 25 km per hour, I need not to have any certification from RTO, or means Road Transport Department, or any certificate from means other any kind of certificates I didn't required for a cycle which is running, or a vehicle which is running 25 km or below per hour. Okay, so even I need not to have a helmet also. I need not to follow the rules also, rules of the road. You can follow for the safety, but not for means even no police person will stop you if you have a this type of vehicle having a less than 25 km per hour. But if you go on a higher side, then you need a testing, you need a certification. So those offices should be there. Let's say we develop one bike. Now the agency should be there who can certify or can testify or can give a certification for the speed and security and so many things like that. Okay. And vehicle servicing, I told you that whenever you purchase any vehicle of Maruti, or maybe the Hyundai or Tata, so you know that we have a lot of service station in the city itself. Okay, so do we have those, or do we have same service station in case of electric vehicle also? So that need to be think out. Okay, consumer perception, raw material for batteries. Even batteries, generally we have a batteries we have a lead acid battery, lithium ion battery, lithium metal halide, lithium metal halide. So many batteries are there. So do we have enough raw material? If you see that, so if you see, lithium ion battery is considered as a good high density wise, and I mean for the efficiency point of view, it is better than the lithium ion, sorry, lead acid battery. Okay, and lithium ion battery is approximately giving around 160 km range. Okay, and in a future discussion or future development or future R&D, lithium ion, lithium sulfur, lithium air, those type of battery are in the picture. Okay, so ultimately what I would like to say that each battery you are expecting to give a high driving range or high efficiency, lithium is always there in that. Okay, but the issue is whether we have a raw material available in a country for this preparation or the manufacturing of this lithium ion batteries. That is another issue basically. So top lithium producing countries are Chile, China, Australia, I mean North America, Brazil. Those are the countries basically. They are having a lithium reserves. Okay, so we're not on the top 10 itself. Okay, and where exactly we are, that is need to be searched out. So ultimately the raw material is also a challenge. If we say that how we will build those lithium ion batteries if we don't have the lithium in our house, or we have to import it. So simply there's another dependency over that. Okay, so I would like to summarize that although barriers are there, challenges are there, but definitely a day will come when a lot of people will have electric vehicles. Okay, or you can say that at a time when solar started, the cost was around 27 or 25 rupees per unit, but you can say now this is around less than 2 rupees per unit. Okay. So this happens because of the technological advancement, advancement in the technology, advancement in power electrons, advancement in the materials of solar panels, and so many things. Okay, so definitely a day would come when we have a good electric vehicle in the market. A lot of people will be using this. So the whatever challenges I have described here, those can be omit out, or those can be met out later. And further, I'll come to those. So these various already I have described, technical various, okay, and all those various I have already described in the slide. So now come to that, what is hybrid electric vehicles? Okay, Since I have a talk lot about this battery. See, battery is the critical issue in a electric vehicle. Okay. So if I don't have a particular range, let's say I am saying that I need to go to Delhi. This is a 300 km. If I don't have a battery which can support me for 300 km, why can't we go for a hybrid vehicle? Okay. So hybrid vehicle basically, whenever your battery, let's say your battery discharges, come to the another mode. That could be your CNG mode, or that could be your fuel, that petrol or diesel, whatever you are using for that. So that is basically a hybrid. Okay. So in order to reduce the dependency on a single source, hybrid word is here. Ultimately, this hybrid word will increase the reliability of the total system. Now, few hybrid things are already in the market. Okay, so I'll also describe what are the types of hybrid are there. So, okay, so what is an hybrid electric vehicle? A vehicle that has two or more energy conversion technologies combined with one or more energy storage unit. So that is basically a hybrid. So now, if we talk about the hybrid electric vehicle, we have a, okay, we have internal combustion engine. That is one thing, spark ignited. Then we have a power electricity with DC-DC converter and battery also. So ultimately, we have a both electric as well as combination of those internal combustion engine. Further, if we move, this is basically the difference between the electric vehicle, hybrid electric vehicle, and another fuel cell electric vehicle. So you can see mainly I'll concentrate to the electric vehicle and hybrid electric vehicle. So propulsion, basically in electric vehicle you have an electric motor drive, but in hybrid electric vehicle you have an electric motor drives and internal combustion engine both. And energy storage subsystem, so battery or supercapacitor you can use. And here in hybrid electric vehicle, battery, supercapacitor, or alternative fuel. For characteristics point of view, zero local emission, high energy efficiency, independent of fossil fuel, relatively shorter range. Since I have already pointed out the shorter range, that's why we are going in a hybrid mode. High initial cost, commercially available. And if we talk about the hybrid electric vehicle, so low local emission means if this is a battery operated, definitely zero local emission, provided if you have a, you are charging from a low carbon grid. Okay. But in hybrid, since this is working on both modes, so you have a low local emissions, high fuel economy, dependence on fossil fuel, long driving range, which was earlier not available in electric vehicle, as I've told you that we need a dependency. So further, long driving range you can get, means once on a electric, once on a battery and another on a internal combustion engine. Higher cost than ICE vehicle, because since you are having a two advantage, so that's why the cost is high, and this is also available commercially. If you move further, energy source infrastructure. In an electric vehicle, these are totally charged from the grid. Okay, but if we talk about the hybrid, gasoline station, electric grid charging facilities for plug-in hybrid, so both modes are available. Okay. Major issues with electric vehicle or hybrid electric vehicle is battery sizing and management, charging facilities, cost, battery lifetime. Because those issues, battery sizing, charging facilities, cost, or battery lifetime, that already I have discussed. But if we go for a hybrid electric vehicle, again, battery management, control, optimization, management, multiple energy sources, those are the challenges basically. So what are the objective of this hybrid electric vehicle? Maximize fuel economy, maximize fuel emission, minimize propulsion system cost to keep affordable, maintain acceptable performance with a reasonable cost, reduce the conventional car weight. Basically, we go for this. First thing is hybrid means the reliability, the increase in the reliability. This is the first thing we need to keep in our mind. So this reliability is also coming with the maximize fuel economy. So with the help of this, let's say what is the per unit cost of energy when you are charged from the electric vehicle or when you charge from the grid, what is the per unit cost of per unit kilometer cost, you can say, when you are going for the fuel. So this is basically the maximizing the fuel economy with respect to the reliability. Okay, minimize fuel emissions, definitely when you have a hybrid mode, so your fuel emission will be minimized. So these are the particular objective when we are talking about the hybrid electric vehicles. Now this is some history. I mean, sometime we have the battery electric vehicle. This was 1830 or 1890. So in 1994, one company built a first hybrid vehicle. Earlier, the attempt were basically 1830 or 1890. The attempt were basically electric vehicle only, but in 1994 they have a hybrid electric vehicle. So in 1990, mass produced Ford car undercurrent hand built electric vehicles. So this is basically the idea was that already I have described that what was the objective in order to create those electric vehicles. Further architecture for hybrid electric vehicles, you have an engine, then clutches, motor, and now the battery comes into the picture. Okay, so you have a battery, then a bidirectional DC-DC means this bidirectional DC-DC can be work for a charging as well as discharging mode. So whenever it required, you can charge it, and whenever battery is used as a source, you can discharge it. Okay. So now ultimately the target to run the motor. When your motor is running, obviously your wheels start rotating. Okay. So now how you are running this motor? That is the thing basically. Either you are generating from the engine with the help of just some generator, okay, or you are running it with the battery. So ultimately the target is just to run the motor. Electric energy transfer is given by a yellow line, and this mechanical energy transfer is given by the black line. So ultimately once you reach to motor, this mechanical energy transfer started. Architecture for this plug-in hybrid electric vehicle. So PV basically, this is a solar-based hybrid electric vehicle. So this is a charging port, PV panels. So you are charging this battery pack either with the help of charging port or PV panels. Then ultimately this battery pack to generator. We are giving energy to generator from the battery pack. Basically battery is on DC, or if you this generator is on AC, so ultimately you can use the conversion from DC to AC, then IC engine. So ultimately IC engine and battery is doing the same thing, running this generator, and ultimately this generator is basically used further for this motor or controller and transmission point of view. So this is a hybrid architecture. Type of hybridization. So this is a, I mean, mild or micro hybridization. This is simply a feature idle stop function, regenerative braking, not capable of using electric motor for propel the vehicle. Basically, in this, you can say that auxiliary supply, whatever auxiliary supply we have in a vehicle, just to support those auxiliary supply, we are using a hybrid mode. That is a mild hybrid, means that electric supply or battery is not used for propelling the vehicle or just to drive the motor. Okay, they have generally a battery of around 42 volt or something. Then further, medium hybridization, future idle stop function, regenerative braking, not capable of using electric motor alone to propel the vehicle. Means this battery is not capable. This is capable of running the motor but not alone. Okay, so the battery voltage is around 144 to 158 volt. Further, if we move, fully hybridization. So here most are capable of using the electric motor alone to propel the vehicle, means the battery is itself capable of running the vehicle now. So that is basically if your one source of energy is gone, or you say let your fuel is finished. Okay, now you can come to the battery mode, or your battery is finished or discharged or drained out, then you come to the oil, like that. So here the battery voltage is around 200 to 300 volt. So we have a type of hybrid basically. We have a A series hybrid, in this the architecture, you can see that you have a fuel tank, you have IC engine, generator, and then ultimately battery or converter. So the ultimate aim is to run the motor. Okay, how we are running the motor. So this is a series hybrid, and now you see the parallel hybrid. You have a parallel combination of this fuel tank, IC engine, and then electric system. This is a parallel. So how you connect that? Either connect in series or in parallel, just like that. Okay. Set of battery that run electric motor, both engine and electric motor can run the transmission at the same time. Now further, this is a combination of series and parallel. Both are there. Okay. Series parallel type, also called power split hybrid, more beneficial than above hybrid. Most of the latest vehicle based on this hybrid basically. So this is a both combination of because uh, from this power converter you can running a motor directly or run the generator then mechanical coupler. So this is basically the interdependency of the system, and the reliability has increased comparatively. So this is a part of the electric vehicle, hybrid electric vehicles. Engine same as other vehicle engine. Engine is same. Size of hybrid electric vehicles engines is small and more fuel efficient. There are two type of engine mostly used in hybrid electric vehicle: petrol or diesel. So this is one out of that. Now second part for hybrid electric vehicle is battery, and means if you say fuel side, this is engine, and if you say electrical side, this is basically battery. So store stores the energy generated from the gasoline engine or during regenerative braking from the electric motor. Type of battery, already I've talked about lead acid battery or nickel cadmium, nickel metal halide or lithium ion battery. Now in future research, lithium sulfur, lithium air, so many things are there. This is basically hybrid recharging. I mean, you can have a hybrid recharging also. You can charge from the grid as well as from the PV panel also. So this is a hybrid charging of a vehicle. This could be a total electric vehicle or also hybrid electric vehicle. We can do the hybrid recharging. So battery used in a hybrid electric vehicle, I've talked about this nickel metal halide, lithium ion. Lithium ion is the basically efficient one. High specific energy and power, high energy efficiency, good high temperature performance, low self discharge or recyclable part in case of lithium ion. So lithium ion is considered good, but still since this lead acid is cheaper, so people are using lead acid also. This electric motor basically part of under part of this hybrid electric vehicle, we have electric motor. Power the vehicle at low speed and assist gasoline engine when additional power is needed. Generally VLDC or DC motors we used. This is a controller. Controller is used to charge the battery or to supply the power to electric motor. So convert DC to AC or like that. So a controller is required when you are going in an electric mode. So this is a generator basically. It converts generally when we have a mechanical part rotating. So we need a prime mover for this generator, and converts mechanical energy from engine to electric energy, which can be used by electric motor or stored in the battery. So those comes in a hybrid also. Also used to start the gasoline engine instantly. That is something we have in right now in our vehicles. So advantage over conventional engine. What are the advantage of hybrid electric vehicle over conventional? Regenerative braking, we can charge the battery. Reduction in engine and vehicle weight. Fuel efficiency increased. Emissions are decreased since you are not running overall, I mean, totally on a fuel mode. So emissions are decreased. Cut emission of global warming pollutant. Reduce the dependency on fossil fuel. Some states offer incentive with owning hybrid electric vehicle. That is basically state-to-state policy. So these are the basically advantage if you are using a hybrid electric vehicles. So challenges are basically energy storage, devices with high power to energy ratio, frequent shutdown and start of the hybrid electric vehicle, reduce the size, weight, and cost. Obviously, weight to body ratio matters, so need to think about the metals or weight of the battery, that how we can reduce the overall weight of the vehicle. High efficiency in conversion of fuel to useful power, because in the earlier slide we talk about that uh, the ratio. Basically, if you talk about the tank to wheel analysis or well to wheel analysis, those conversion efficiency was really low. So need to think about the high conversion efficiency. Advanced configuration for the propulsion system component. So these are the things basically we can incorporate in those vehicles. Now, all major automobile manufacturers are working on hybrid electric. Even already a few cars are available in the market which are basically on hybrid side. Heavy vehicles like trucks will be use hybrid system in future. Efficiency of hybrid electric vehicles will be further increase in future. Safety features will be add in new generation hybrid car or other vehicles. Power of car have to increase in future. So ultimately, this is hybrid system is, because I talk about that in electric vehicle we have a issue of battery efficiency or wide range or swappable battery station. So many things I have described. So if we use those hybrid, then definitely there's a win-win situation for all. So this is basically a Tata product hybrid bus they have made, super capacitor and on fuel. So now this is from my side on hybrid vehicle basically. Now I'll talk about my lab. I joined around 4 years back in MNIT Jaipur, and we have established one lab that is basically a smart energy and sustainable research lab. We have a few funded projects in that lab. We are primarily working on electric vehicles or microgrid. So in this lab, basically, we have these funded project. In first project, that is basically given by DST under Mission Innovation, we are developing a microgrid in a village in a village near MNIT. This is around 16 kilometers from MNIT. So in this microgrid, the beauty of this microgrid or the research in this microgrid is basically this is a standalone itself, and we are not using any reference generation. The reference generation is given by the battery itself. So this is a big thing, how we have controlled that. So this is in the deployment stage basically. I hope next 1 or 2 months we are able to develop and deploy this. So this is around the 3 crore grant. IIT Delhi, IIT Jammu, and IIT Hyderabad is a partner in that, and MNIT Jaipur is leading. I am PI for that, and means around 80 to 83 funding is with the MNIT only. So we are developing it. This is one project. Second is basically we are developing the chargers for electric vehicles. We have developed up to 1 kilowatt, and those we are using in our cycles or bike. So we have filed few patent also and published in IEEE transaction or IIT Power Electronics. So this is project already finished in March this year. And one more project, that is Spark grant we have, that is basically academic and research cooperation with foreign universities. So we have a University of New South Wales, Australia, and University of Concordia as our partner in this. Our student can visit those universities for 3 months. Their student can visit to us. Faculty member can go there, and faculty member from those university can come to us and can work jointly with us. So this is a grant basically around 1 crore we have, and a few more projects we are waiting actually. So few more projects has to come in our lab. Ultimately, I'll talk about, since I'm talking about the vehicles and electric vehicles or hybrid electric vehicles, so I'll talk about the only one project, which is the investigation of various unidirectional and bidirectional electric vehicle charging discharging configurations. So that is basically chargers which we have developed in lab. So basically, when you are developing a charger, so the things which should come in your mind, that is basically the cost, weight, size, and efficiency. Cost, weight, size, efficiency. So you have to reduce the cost, weight, and size, increase the efficiency. So these things were in our mind, and with a topological change or by doing some combinations or by using the power electronics which we have with us, we develop a few chargers basically. So I don't know how many are in the, I mean, listeners, how many are from electrical engineering, but I'll try to make it generalized. So the main thing which we did here is basically to develop a charger with low cost, weight, and size. One company approaches with their charger, and they told us this is a 3 kg of weight and 70% efficiency. We reduced the 3 kg to 1 kg, and efficiency increased around 90%. So this is because how we select the switches, MOSFET, IGBT, and what kind of changes we made in the circuit diagram in order to get the required weight and reduce the losses like that. So these are the chargers basically we developed. Everything we did from scratch in lab itself, starting from PCB design to PCB fabrication and inductor design, inductor fabrication. By using this DSP control, we made those chargers. So, and these are compared with the existing chargers, and we found that in terms of efficiency and all, our charger is much better than the comparatively other chargers. Okay, so our charger were working fine in a light load condition and heavy load condition compared to the other one, and having a less component. Once you reduce the component, obviously the size, weight, cost is reduced, and once you reduce the losses, that maybe by the particular switching or maybe by the particular component selection. So once the losses reduce, your heat sink requirement is also reduced. Let's say earlier losses were high, so heat sink was quite the weight of the heat sink was quite high. Okay, so reduce the losses, reduce the weight of the heat sink, then ultimately overall size of the charger or weight of the charger will reduce like that. So we worked on that principle and we made those chargers, and right now we are using them in our cycle also, and we have filed one patent also for the same. So you can see that we are able to increase around 6% efficiency in 1 kilowatt. So when you are talking about the 1000 watt, so around 60 watt changes there. So 6% is a huge when you are talking in terms of efficiency. And this is this is basically the charger which is given to us by the industry, and we modified it and reduced the weight and size. Ultimately, bidirectional power flow is there, means you can charge the battery and same time you can discharge the battery also. Okay, and this is a universal charger which can work in charging mode, discharging mode, propulsion mode, and regenerative braking mode also. This published by one student in IIT Power Electronics, by MTech student. And further we talk about the wireless charging also. This is a work of one of the PhD student. Here we have a transmitter coil and receiver coil, and the distance between transmitter receiver coil is 27 centimeter, or you can say 270 millimeters. So this gap is enough as per the ground clearance in the vehicles is required right now, or present in the vehicles right now. So transmitter coil receiver, and finally this is a battery we are charging it here. So this is a wireless charging. Further, my student have started one this startup, since Government of India given mandate in 2019 to faculties of MNIT and IITs, they can have a start. So my student started this startup basically in MIAC, Malviya Innovation Incubation Center. So we are developing those. I am just a mentor for those students. They have developed these cycles, basically e-cycles, 25 kilometer per hour, and the specifications are there. 2 hours, it took around 2 hours to get it fully charged. So these are the another models basically developed by the student. This is a e-cycle come e-bike. Speed is 25 kilometer per hour. And now they have a change in the design. This is a battery basically. The black one you are seeing in this is a battery. So they went to battery industry. They learn how to design it and then perfectly work with them and come out with this type of design model. If we move further, these are another model developed by the student for e-cycle. This is how we work. So these are the cycles made by our student in an incubation center. This is our team, and ultimately this is we tested for e-cycles last year, I think. So this is all from my side. This is few publication from the lab. Since I am from electrical engineering background, so I was more on electrical side. But yes, I tried to justify what exactly electric vehicles and hybrid electric vehicles are, and what exactly we are doing in lab. So now I'm open to your questions and answers. Please,
Yes, sir. So thank you, sir. So there are a few questions in the chat box. Let me read it out.
let me go. I'll go to chat box.
Yes, sir.
So do EVs lose charge when parked? If you park it for a long time, definitely they lose charge. You can see this in our own conventional vehicle also. If you park it for 2 months or 6 months, definitely the battery got discharged. So sometimes we say that is at least move this vehicle in a week, once in a or twice in a week. So definitely they lose charge when they parked for a long time. Now, how battery swapping technology help to reduce the charging time? Basically, a battery swapping technology is nothing but just like you have a stepney in your scooter or your car, that you have an extra wheel. Okay, so once one got punctured, you go to the mechanic and just exchange it. Okay, and further, so this is the same kind of battery. You have two batteries. Okay, one battery is fully charged and one is discharged now. So you go to the swapping station, discharge battery you can hand over them, and fully charged battery you can take. Okay, so the earlier fully charged battery which you kept in idle mode now can come to the work, and now you have extra battery with you for a emergency, you can say. Is it okay? Now, how efficiency of battery can be understood? Efficiency of batteries, basically we can say that, yeah, this is some one question one reviewer asked me in one of my paper. So basically, efficiency of battery, you can say that how many kilometers it can travel. Okay, so we can say that, I mean, high energy density. So lithium ion battery is more capable in that. So in terms of driving range, you can say the how much battery is efficient. That is something we can talk about. So if you have a further question, please let me know.
Yes, sir. I would like to request participants to post the queries in the chat box.
Or not only chat box, they can ask me also one by one. That is also possible.
Sir, I have a doubt regarding battery swapping.
Huh.
Sir,
Battery swap.
do we
Huh.
have any universal common battery that it can be replaced with all the vehicles?
That different vehicle have a different requirement. For example, cycle, they have a different requirement. Low segment electric vehicles, they have a different requirement. If you go for a buses or if you go for a trucks, they have a different requirement. So universal battery is a different thing basically. But
Yes.
we can think of segment wise. Let's say lower segment we can have a one way universal battery. Mid segment we have a universal battery, and large segment we have a universal battery. Just like that we can think about.
Yes, sir. Yes. Thank you, sir. So I don't think so any more queries from the participants. So shall we wind up the session, sir?
Yeah, yeah, sure, sure.
Yeah. So thank you so much for the informative session, sir.
Okay. Thank you. Thank you very much.
You can stop
Yeah,
presenting.
yeah.
Yes. So I would request participants to fill this feedback and attendance link of session 2, which I have posted in the chat box. And the next session will start at 2 p.m. Okay, join with the same link at 2 p.m. So thank you, everyone.